Hi, I'm John.
And I'm Becca.
Normally we test our devices to the extreme.
But today we've decided to send these two devices into space.
So let's go meet some specialists to help us out to do this. So Chris, this is one of the payloads we're using, yeah?
It is, John, yeah. So we want to keep things as simple as possible. You can see we've stripped as much away as possible because weight is always a concern for us. We want to get this thing as high as possible. We want to get the blackness of space, the curvature of the Earth, and we're going to do that using this attached to a big meteorological balloon.
What sort of speed are we going to see this ascending into space?
We have seen that 6.5 meters per second ascent rate serves us best. However, when this thing bursts, we're going to see much more dramatic speeds, easily in excess of 250 miles per hour. So this thing is going to experience one hell of a journey.
Oh, wow. So we've done all the launch planning. We're just about to set off, jump into the vehicles and go and launch this product into space. So exciting times.
The first product we launched was the FZ-N1, the smaller of our two devices. The harsh conditions of near space requires precision planning. The payloads are bespoke built, made of polystyrene to insulate and protect the onboard cameras so they can cope with the extreme drop in temperatures, up to minus 60 degrees Celsius at the top of flight. One final job was to get all the relevant clearances from the Civil Aviation Authority and the Notice to Airmen, and we're off!
So we've just launched the balloon. It's just gone through the clouds after about 2 or 3 minutes. The challenge now is we've got to pack up as quickly as we can, get into the vehicles, chase the balloon down and retrieve it. So here we are, we're in the chase down vehicle. This is where all the fun continues. So we've just done a check. We've got a live radio link up to the device. Louis just told us it's about 19 kilometers in height, which is the commonly accepted gateway to space, the Armstrong line. We've got an estimation of where the device is going to land, so that's why we're in the tracking vehicle now, keeping this live radio link going to find out exactly where it's going to land, and hopefully we'll be in a position where we can see it come down back into Earth.
All we wanted to do was to get to the product as quickly as possible to see if it had worked. Had the device survived? Had the cameras captured the journey to near space?
Absolutely fantastic. I'm gobsmacked. Brilliant. What do you think, Becca? First time this has been into space, coming back, working fine. Yeah, look at that. Brilliant.
With the FZ-N1 launch success, we waited with anticipation for the launch of the SZ-G1. We opted for a new launch site with different weather conditions and an increased weight and device. Weather forecasts were predicting that this payload was going to travel considerably further than the FZ-N1. This meant time was really of the essence and our chase down was critical. One final clean-up of the screen and it was all systems go, as we watched the device head off into the skies. What was really cool was we were using the FZN1 to track the FZG1 in near space. It's hard to believe that this device had done the exact same journey the day before.
How's it looking? Shall I power it on?
Alright. Yeah.
Yes.
What about that then?
Powered on.
Works?
Yep.
On it comes.
It's on.
Fantastic.
Yeah, it's on. Cool. No damage.
Brilliant.
Bit of grass. A bit of impact on the corner, yeah. Windows 10, yeah. Superb.
This looks suspiciously to me like it's still recording.
Say hello.
So John, it's been a long 2 days. We can finally say these two devices have been to space.
Yeah.
So remind me again, how high did they go?
3 times the height of a jetliner, a jumbo jet. Temperatures lower than -60, which is it's the most extreme testing that's ever been done for a Toughbook or a Toughpad. So excellent, well done.